Tokyo is the largest metropolis on Earth. 37 million people living, working, and sleeping under a sea of neon lights. At first glance, it's the pinnacle of human civilization, an invincible fortress of steel and glass. But Tokyo hides a terrifying geographical flaw. During the 20th century, the city extracted so much groundwater for its industry that it literally sank. Today, nearly 3 million people live in areas below sea level. For all practical purposes, Tokyo is a giant bowl. And that bowl is surrounded by 5 massive river systems, sitting right in the path of the Pacific's most destructive typhoons. When millions of gallons of rain hit solid asphalt, the water has nowhere to go. It becomes an unstoppable monster of pressure. To understand why Japan spent over $2 billion on this hidden trap, we have to look back at the nightmare of 1947. Typhoon Kathleen slammed into a post-war Japan that was already struggling. The rivers surrounding Tokyo didn't just overflow, their banks catastrophically failed under the pressure. Over 300 square kilometers of the city were swallowed by dark, toxic floodwaters. Thousands of people lost their lives, and hundreds of thousands were left homeless. This wasn't just heavy rain. It was an existential threat to the nation's survival. The government swore a disaster of that scale would never happen again. In 1992, the Japanese government realized they couldn't build giant dams on the surface. So they looked down. 50 meters below the asphalt that millions walk on every day, they decided to build the largest water management infrastructure on the planet, the Gikans Project. If you descend beneath the suburbs of Tokyo, you won't find simple pipes. You will find the first line of defense, the silos. Imagine 5 colossal vertical shafts dug directly into the Earth's crust. They are so massive you could fit an entire space shuttle inside just one of them, with room to spare. When surface rivers threaten to overflow, the water is diverted into these abysses. But here arises the first problem of extreme engineering. If you drop millions of gallons of water in free fall from 70 meters high, the kinetic energy would shatter the concrete floor. Water acts like a giant hammer. To solve this, engineers use a fluid dynamics concept called vortex flow. The water doesn't fall straight down. The silo walls are designed to force the water to spiral, creating a liquid tornado that clings to the sides. This dissipates the kinetic energy through friction, allowing the water to reach the bottom without destroying the structure. Once the water survives the drop, it doesn't just stay there. These 5 abysses are connected by a colossal underground tunnel over 6 kilometers long. A dark, artificial river running directly beneath the homes of the city. Building a 10-meter diameter tunnel under a living city is a logistical nightmare. Engineers had to use giant tunnel boring machines, digging at a depth of 50 meters to avoid crashing into subway lines, internet cables, or skyscraper foundations. And all of this while dealing with the immense pressure of the Earth constantly trying to crush the tunnel. How exactly do you dig a massive void in soft, watery soil without the city streets above caving in? The answer is a piece of extreme engineering known as an earth pressure balance shield. It's essentially a 100-meter-long mechanical worm. The front features a massive rotating cutter head covered in titanium teeth that grinds through the rock and mud. But the real genius is what happens right behind the blades. As the machine eats the earth, it uses the excavated mud itself, held under extreme pressure, to support the tunnel face so it doesn't collapse. At the exact same time, robotic arms inside the machine are installing heavy precast concrete rings behind it. The machine literally builds a waterproof pipe around itself while simultaneously moving forward. It leaves behind a perfectly finished tunnel, leaving the millions of people sleeping in the houses above, completely unaware of the massive operation happening right under their beds. All that violent flow travels through the tunnel at terrifying speeds until it reaches the heart of the system. The surge tank. Engineers call it infrastructure. The rest of the world calls it the underground temple. It's an artificial cavern the size of 2 soccer fields, held up by 59 massive concrete pillars. Each pillar weighs 500 tons. You might think these pillars are there to hold up the ceiling, but the truth is the exact opposite. They are there to hold the floor down. There is a physical force called hydrostatic uplift. Think about when you try to push an empty beach ball to the bottom of a swimming pool. The water around it pushes it towards the surface with brutal force. On a massive scale, any hollow, airtight structure suffers this exact same effect. The underground temple is a gigantic concrete beach ball. When the earth floods from a typhoon, it acts like an underwater air balloon. If these pillars weren't so heavy, the buoyancy force would lift the entire compound. Bursting through the earth's crust and destroying the city, the pillars are anchors. But if you look closely at these 500-ton anchors, you'll notice something strange. They aren't perfectly square, and they aren't perfectly round either. They are shaped like elongated ovals, closely resembling the wings of an airplane. This is another stroke of engineering genius known as hydrodynamic profiling. If the pillars were flat squares, the raging water rushing towards the pumps would crash violently into them. This would create massive underwater turbulence, potentially eroding and destroying the concrete over decades of use. The oval shape allows the monstrous current to slice smoothly past them, minimizing resistance and keeping the flow perfectly stable as it approaches the turbines. The temple serves another vital purpose, slowing the water down. This prevents a destructive effect called cavitation. Have you ever seen a boat propeller spin so fast that it leaves a white trail? That's not heat, it's pressure. When liquid moves at extreme speeds, the pressure drops so suddenly that water tears itself apart, creating microscopic vacuum bubbles. If the water entered the pumps at full speed, these vacuum bubbles would form. As they crashed against the steel blades and collapsed, they would generate mini explosions and shockwaves capable of ripping chunks of solid metal apart. Furthermore, any sudden change in pressure would create a water hammer, a seismic wave of water that would blow the pipes apart.
Acts as a giant shock absorber.
It calms the beast down before the final step. But this entire mechanical beast would be useless without a brain. Hidden in an unassuming building on the surface is the central control room. It looks exactly like a NASA launch center. The engineers sitting in this room receive real-time data from hundreds of radar sensors, weather satellites and river gauges spread across the entire Tokyo metropolitan area. They can't just run the system on autopilot. If they pump too much water too quickly, they could accidentally flood the exact rivers they are trying to protect downstream. It is a highly stressful game of hydrostatic, where human engineers must perfectly calculate the exact second to unleash the system's full power. And the final step is to expel the water. Hidden at the end of this temple are 4 monstrous impellers. This is where engineering merges with aerospace technology. To power the impellers, they don't use giant electric motors. Instead, they use modified gas turbines, similar to those found on a Boeing passenger jet. Generating 14,000 horsepower each, they are completely independent from the power grid. When engineers fire up these engines, they suck the water out of the temple and shoot it into the Edo River. The power is so absurd that these 4 pumps combined could empty a standard Olympic swimming pool in just 1 second. But hold on, because shooting 200 tons of water per second into a nearby river creates a brand new problem. Think about it. What happens if the Edo River itself overflows from this massive sudden artificial tsunami? Japanese engineers, of course, thought of that too. They knew they couldn't rely on traditional flood walls. A normal concrete wall is just a thin, high barrier. If the water pushes too hard, the wall cracks, breaks, and the city floods in seconds. So they transformed the banks of the Edo River into what they call super levees. Instead of building a fragile wall straight up, they elevated the ground itself outward. Imagine a gigantic, gentle, artificial hill that stretches hundreds of meters inland. It's so wide and stable that entire neighborhoods, streets, and parks are built right on top of it. This way, if the river swells to apocalyptic levels from the pumps, the water doesn't crash against a wall. It simply creeps up this armored slope. The water is safely contained and the city's final defense never breaks. But the story doesn't end when the storm passes and the sky clears. When the water drains from the underground temple, it leaves behind a massive, dirty problem. Hundreds of tons of toxic mud, debris, and silt covering the entire cavern floor. If left alone, this mud would harden like solid rock, destroying the delicate machinery and rendering the temple useless for the next typhoon. So, how do you clean an underground cavern the size of a shopping mall? Engineers open massive hidden hatches built into the surface streets above. Then, using heavy industrial cranes, they literally lower full-size bulldozers and excavators 50 meters down through the ceiling and straight onto the temple floor. These machines spend days scraping the concrete perfectly clean, ensuring the beast is ready to fight another day. Every year, while the citizens of Tokyo sleep, an epic battle is being fought beneath them. Jet engines and water tornadoes fight against nature, and they win. The next time you walk through this city, remember that the true marvel isn't the skyscrapers touching the clouds. It's the invisible engineering beneath your feet. Subscribe and hit the bell icon to discover more secrets of the real world.